Okay, so chapter 2, we're going to be discussing some basic math skills. So chapter 2 starts out with discussing whole numbers. So it's important to note that whole numbers always appear to the left of the decimal point. So if I have the number 15, for example, whole number 15, if I follow that up with 0.000, this could continue on and on forever, still just going to be a value of 15. So we're always to the left of the decimal point here. So also, calculations with whole numbers always yield whole numbers. So you're never going to add, subtract, multiply, or divide whole numbers and end up with a decimal or a fraction. Your number will always be in another whole number. So this chapter goes into great detail on how to add, subtract, multiply, and divide without a calculator. I'm not going to get into all of that because we will have access to a calculator in class. You will have access to a calculator in the pharmacy. So if you are having issues with adding and subtracting, multiplying, or dividing with a calculator, please see me as soon as possible. I will be more than happy to walk you through how to do that. What I want to focus on in this video is fractions. Okay, so any of those simple calculations with a calculator that you are not comfortable with, see me, we can address that. So I wanted to start with fractions here. Fractions are always expressed as a number over another number. So in this case, we have A over B, okay? Now A is always our numerator and B is always our denominator. So we're going to first discuss proper fractions. So where our numerator is less than our denominator. So let's just start with an example here. Let's look at 1/2. So this is 1 over 2. Same thing, any fraction is also, we can look at that as a division problem. So 1 over 2 or 1 divided by 2, okay? Now we consider this to be a proper fraction because the numerator is smaller than the denominator. Now an improper fraction would be the opposite. So if we had, for example, 5/3 or 5 over 3, 5 is larger than 3, so that would be an improper fraction. We can also have what we call mixed numbers. So for example, 2 and 1/4. So a mixed number is always going to be a whole number followed up by a fraction. So once again, this is proper, improper, and a mixed number. Now we're going to discuss how to convert between both improper fractions and mixed numbers here. So if I wanted to change 5/3 into a mixed number, so where we start, we always take the numerator and we divide that by the denominator. So like I said, a fraction, you can always look at it as a division problem. So first we want to see how many times does 3 go into 5? Well, we know that 3 will go into 5 one time evenly, but we're going to have 2 left over because 5 minus 3 would be 2. So there's a remainder of 2. That's what we'll use in our numerator. And then we just keep the same denominator. So we'll just keep that as 3. So 5/3 is the same thing as 1 and 2/3. Now, to confirm that, I'm going to show you how to go back the other way. So now, going from a mixed number to an improper fraction. So always take your whole number, multiply that by the denominator. So 1 times 3 is 3. And then we're going to add the numerator. So once again, 1 times 3 is 3, plus 2 would give us 5. Keep the same denominator. So 5/3, just going back and forth. So now we can practice here with this mixed number. We had 2 and 1/4. So once again, take your whole number times your denominator. 2 times 4 gives us 8. And then we're going to add the numerator. So 8 plus 1 would give us 9. Keep the same denominator, which would be 4. So we have 9/4. Now to practice going back the other way, so turning this back into a mixed number. So going from a improper to a mixed, we always want to take our numerator divided by our denominator. So 4 will go into 9 a total of 2 times. We know that 2 times 4 is 8. So 9 minus 8 would be 1, so that would be our remainder. And then we keep the same denominator. So 2 and 1/4 once again. Okay, so the next concept we have adding and subtracting fractions. Now, first rule, when the denominators are the same, it's very simple. All we have to do is either add or subtract the numerators and keep the same denominator. So I'll show you an example of that in just a second. When the denominators are not the same, however, then we're going to have to find the lowest common denominator and make all of the denominators the same before we can add and subtract. So let's look at an example here when the denominators first are the same. So let's say we have 2/3 plus 4/3. So denominators are the same. This is an addition problem. All we have to do is just add the numerators. So 2 plus 4 is 6. Keep the same denominator. So 6/3. Now we notice this is an improper fraction, so we need to change that into a mixed number. So remember, to do that, we take the numerator divided by the denominator. So 3 will actually go into 6 an even amount of times. So 3 goes into 6 a total of 2 times. So there is no remainder left over. So 2 is our final answer. Now, one more example with the denominators being the same. We'll do a subtraction problem here. So 5/7 minus 2/7. This is a subtraction problem. The denominators are the same, so we can keep the same denominator and just subtract the numerators. 5 minus 2 is 3. That is a proper fraction. The numerator is smaller than the denominator, so we can just leave our answer as is. Now, let's look at some examples where the denominators are not the same. So let's say we have 5/6 plus 1/4. Now, our denominators are not the same. We cannot just add them together. We need to find what we call the lowest common denominator. So we want to find a number that both 6 and 4 can go into. So just thinking about my multiples here, I know 6 times 2 is 12, and I know 4 will also go into 12 evenly. So I want to pick 12 as my new denominator. So now we need to just look at each fraction individually. So I want to think in my mind, how did I get from 6 to 12? Well, I multiplied that by 2. 6 times 2 is 12. So whatever I do to the bottom here, I want to do to the top as well. So 5 times 2 is 10. So I just converted 5/6 into 10/12. Now I want to do the same thing for 1/4. So I look at my 4. How did I get from 4 to 12? Well, 4 times 3 is 12. Whatever I do to the bottom here, I want to do to the top. So 1 times 3 is 3. So I've changed 1/4 into 3/12. So now that my denominators are the same and I am adding, keep the same denominator and just add your numerators. 10 plus 3 is 13. Now 13/12 is an improper fraction, so I need to reduce this to a mixed number. So I know that 12 will go into 13 a total of 1 time, and there will be 1 remaining, and we just keep the same denominator. So 1 and 1/12. Let's do one more example like that here. Let's say 7/8 minus 1/3. So once again, my denominators are not the same. I need to find a lowest common denominator. It really doesn't even have to be the lowest common as long as you find a number that both of these numbers will go into. It may just require a little bit of reducing further at the end. So right off the bat, I think to myself, well, 8 times 3 is 24. I know both of those numbers will go into 24. So we can use that here. So let's use 24. Now, to get from 8 to 24, I took that times 3. So I need to do the same thing to my numerator here. 7 times 3 is 21. Now, from 3 to 24, I took that times 8. So I want to do the same thing to my numerator. 1 times 8 is 8. Now my denominators are the same, so I can just subtract my numerators. So 21 minus 8, what would that be? 20 minus 7 would give us 13. So 13 over 24. I don't believe I can reduce that because 13 is a prime number. I can't divide that by anything evenly. My numerator is smaller than my denominator, so this is a proper fraction. So we would just leave our answer as 13 over 24. Okay, so the steps for finding a lowest common denominator, if you're still struggling with that, there's another example here in your notes. Now, reducing fractions. So we've kind of been doing this already a little bit, but let's go through a couple more examples on how to reduce fractions to the lowest term. So make sure in your assignment that you always make sure that your fractions are reduced to the lowest possible proper fraction unless it asks you otherwise. So let's see. Let's look at this fraction here. So 48 out of 120. I want to reduce this down to the lowest possible fraction that I can. And it's okay if right off the bat, you don't know exactly the largest number that will go into each of these. So we can just kind of break this down a little bit. Just looking at this, I know that both of these numbers are divisible by 4. So if you need your calculator, feel free, use that. I know 48 is divisible by 4, so 48 divided by 4 gives us 12. So we just divided this one by 4. Whatever you do to the top, just make sure you do to the bottom as well. So 120 divided by 4. If you need to use a calculator, once again, go ahead. 120 divided by 4 gives us 30. Now, I know that these numbers can still be reduced. I know they can at least be reduced in half, but just looking at these, I know that 6 will also go into both of these numbers here. So 12 divided by 6 would give me 2. 30 divided by 6 would give me 5. So like I said, it may take you a couple tries to get these down to the lowest proper fraction. However you need to do it will be just fine. Just make sure in your assignments that you are reducing everything to the lowest terms. All right, now we're going to look at multiplying fractions. So multiplying fractions is pretty simple. You just multiply your numerator times your numerator and your denominator times your denominator, and then you reduce. So here's one example here. I'll show you a few others in just a second. And I'm also going to go through how to divide fractions as well. So let's see here. Let's do 4/5 times 6/9. So this is a multiplication problem. So anytime you multiply fractions, just multiply straight across. So 4 times 6 is 24. 5 times 9 is 45. Now, can these numbers be reduced? Looks like I know they can at least both be divisible by 3. So 24 divided by 3 gives us 8, and 45 divided by 3 gives us 15. Now, I don't think there's a number that will go in evenly to both of these numbers, so that is where we'll have to end. That would be our proper fraction there. One more example with multiplication. Say 1/5 times 8/17. So we'll make it a larger denominator there. So once again, if you ever see multiplication, just multiply straight across. 1 times 8 is 8. 5 times 17, need my calculator for that one, 85. So 8/85. And I cannot find a number that is going to go into both of these numbers evenly. So that is where we would leave our proper fraction there. Okay, now dividing fractions. First, any mixed number, make sure you change that into an improper fraction first. I should have mentioned that with multiplication as well. We can go through an example real quick on that. And then with division, you're going to invert the divisor, which is the same thing as inverting the second fraction that we see, which I'll explain that when we see an example here. So we're basically just going to flip the second fraction and then change the problem into a multiplication. So let's first look at an example. Let's say that we had 3 2/5. We'll go back to multiplication real quick. Times 1 1/4. So these are both mixed numbers. The easiest way to do this would be to change these into improper fractions first. So as a reminder, take your whole number times your denominator. 3 times 5 would give us 15, plus 2 would give us 17, and then we just keep the same denominator. Now, same thing here. 1 times 4 is 4, plus 1 is 5, keep the same denominator. Now that we have a multiplication problem, just multiply straight across. 17 times 5 is 85. 5 times 4 is 20. Now, this is an improper fraction. Our numerator is larger than our denominator, so we need to change this into a mixed number. So 20, I know will go into 85 4 times evenly, because 20 times 4 is 80. So 85 minus 80, there would be 5 left over, and we'll keep the same denominator. Now this is a mixed number, but this fraction can still be reduced here. So still going to be a whole number 4. Now I know that 5 will go into both 5 and 20 here. So if we divide by 5 here, that will leave us with 1/4. So 5 divided by 5 is 1, 20 divided by 5 is 4. So my final answer would be 4 1/4. Now, let's take a look at some division problems with fractions. So let's say 9/13 divided by 2/5. So the trick with division, we're going to invert this second fraction, which just means flip the numerator and the denominator. So keep your first fraction, change your sign to multiplication, and flip your second fraction, 5/2. Very simple, just flip your sign, flip your second fraction. Now we have a multiplication problem. Anytime you see multiplication with fractions, multiply straight across. 9 times 5 is 45. 13 times 2 is 26. We have an improper fraction here, so I need to change that to a mixed number. I know 26 will go into 45 one time, and the remainder here, we would take 45 minus 26. That would leave us with 19. Keep the same denominator there. 19 is going to be a prime number, so that would just have to be left as is there. So 1 19/26. All right, one more example with division. We'll say 5 2/3 divided by 1 1/6. So we got two mixed numbers. Got to change them into improper fractions first. 5 times 3 is 15, plus 2 is 17. Keep the same denominator. 1 times 6 is 6, plus 1 is 7. Keep the same denominator. Now this looks a little bit better, so we can use our trick. Keep the first fraction, flip our sign, and flip the second fraction. So 17 times 6 gives me 102. 3 times 7 is 21. Now I need to see how many times will 21 go into 102. Well, I know it'll go a total of 4 times. 21 times 4 gives me 84. So then I would take 102 minus 84, which would give me 18. Keep my same denominator there. And just looking at this, I know that 3 will go into both of these numbers here. So keep my whole number. 18 divided by 3 is 6. 21 divided by 3 is 7. So 4 and 6/7 would be our final answer there. Okay, so once again, there is an example for how to divide fractions in the slides as well. If you have any questions over what I've covered in this video, please see me as soon as possible. Shoot me an email or talk to me in class on your lab day.